I'm Mark Ellison, Chairman of the WPCA. Let's call this meeting to order. Special meeting Wednesday, December 16th, 2020. Unless there's any proposed changes to today's agenda, we will proceed as posted. Building communications, there are none that I am aware of. New business, we have 4 items on today's agenda for new business. We have 4 meetings, 4 presentations from 10 to 10:30, 10:45 to 11:15, 11:30 to 12, and 3:30 to 4. Given that we'll probably start around 10:05 or so, we will adjust the first presentation, which is from D&B Engineers and Architects, from 10:05 to 10:35. And that's about as much as you'll hear out of me. I will now turn things over to Chris for the day.
Good morning. Chris Ryder, Store Inspector, Administrator for the town. Just a little overview on the project. As you know, it's about 313 feet through a wetlands. The sewer pipe is on wood piles. It currently needs to be upsized from a 33-inch to a 36-inch pipe. There is a tapped membrane from one side of the project. There's going to be quite a bit of permitting required for this project. So from here, I'll hand it over to the D&B engineers for their presentation.
Could I just ask everyone to go on to mute unless you're presenting? Thank you. Do we have the team from D&B here? I think you're muted.
You're muted, Adriana.
Thought I was using the phone. Do you hear an echo now, or?
No, we can hear you.
Oh, okay. I thought I didn't need to be unmuted. So is Robin?
I don't see Rob yet.
Hello.
Oh, there we go, Rob.
Yeah, I'm having a problem with the screen, though, for whatever reason.
Okay.
Is that all right?
Okay. Yeah, you could, but you have the presentation in your computer, correct?
Yeah, I can pull that up.
Okay.
All right. I'm sorry about that.
It's 2020. Anything goes.
Sorry. Okay. Can I start? Actually, I know what my parts are, so. Okay? Can I start?
Yes, I have the cover slide.
All right, everyone's there now. Okay. Okay. Well. Okay. Well, good morning. My name is Rob Rabb. I'm a senior vice president here at D&B Engineering and Architects. We're a firm that's been around for about 55 years. I've been here about 13 years, and I've been asking around. I'm not sure if we've worked in Fairfield before. However, I know we've had a lot of experience in neighboring Bridgeport, where we've been working for 12 or 13 years now. However, the firm has been around for 55 years. We are primarily, from the beginning, have been a wastewater, water, and an environmental firm doing a lot of hazardous material work as well. We have over 200 employees, engineers, architects, various environmental professionals. We have our main office is on Long Island in Woodbury, and we also have an office a secondary office in White Plains, not far from where Fairfield is. We're very happy to be able to submit on this. This project is something that we're very familiar with as far as the type of work. We've done very similar projects, and we're going to be getting into a couple of projects that we've done already. The firm itself, we've been pretty much, I would say in the last 10, 20 years, been in the top 200 within the Engineer News Record poll every year as far as environmental firms. We have, for this project, we've assembled a team of 4 professional companies. We have D&B. We also have, I'm not sure if you're familiar with them, but Pereira Engineering. They're a local firm actually in Shelton that we've been teaming with on Connecticut projects since, I think, about 2009. We also have Musa Rutledge that we have also teamed on many projects, and it's my understanding that they've actually worked on some projects as well in Fairfield. Now, Musa Rutledge will be our geotechnical partner. We also have working with us is a firm, Thunderbird, that will be doing our environmental evaluations and submittals. And in addition, we have NASCO. I'm not sure if you're familiar with NASCO. They're a well-known cost estimating firm that will also be assisting us. I guess what's the next slide? Well, I guess I went through this is a little awkward without having this. Actually, the slides I have it's difficult to get on my screen here. But let me, if I can, what I'd like to do is really get into the heart of the discussion. And what we have are 4 projects that we feel would be a good representation of what type of work we've done in the past. And if I can, I'd like to start with the Bridgeport project because it has a lot of similarities, and it also has our experience working in your basically geographical area. When I guess about 8 or 9, actually 10, 12 years ago, we were retained by the city of Bridgeport to evaluate their stormwater system and their wastewater system, which is, in the case of Bridgeport, is a combined system. For years, I guess from the early 1900s, they've had a combined system, and they really haven't done much up to the year 2000. They've done studies, but they really haven't done any separation. And because of the contamination into the waterways, as well as Ash Creek, for example, which is, important in this project as well, we actually did a design to look at all of the areas in the southern part of Bridgeport, their main area, the downtown area, the east area, and also around by the university, and also in the area of Ash Creek. Now, if you're familiar with Bridgeport, they have 2 treatment plants, the east and west, and most of the work and most of the sewage that we're dealing with, the piping systems, actually go to the west plant, and that's where the project I like to talk about is impacted. Okay, in the area of just north on Boswick Avenue, I'm not sure if you're familiar with Boswick Avenue. If you're on Boswick Avenue and go south, it goes to the west plant. Now, historically, the whole area in the Ash Creek area, they've had a combined sewer, and what they found, there was a lot of contamination going to Ash Creek as the regulators in the system were backed up, and you'd get an overflow, and the contamination would go into the river there, or the creek. Unfortunately, what they tried to resolve it in the late 1990s, and what they did was they put a second pipe running down from the Ash Creek area to the treatment plant in excuse me, in the east, in the west area. Excuse me a sec. So what happened was the pipe that extended down, the new drainage pipe, there was a conflict. And what they realized when they were bringing this pipe down is that they couldn't separate the pipe and bring it to an existing outfall because of a conflict in the road. So what we were tasked to do was actually build an underground pump station to take that stormwater and actually direct it above the conflict, which was a 345 kV electric line, and to actually bring it to a drainage line. And what we did, though, because, right, the two pipes that came down, the stormwater and the wastewater pipes that were coming down from Ash Creek area into the existing treatment plant, we had to remove the stormwater flow and actually pump it up and out. So that was a very interesting project, but there were a lot of conflicts, and there were a lot of utilities in the way. Excuse me. There was a problem with the 345 kV, which we had to go around, and it ended up being a very excuse me. Sorry, I have a cold today, and so it's been a very successful project. So that was the one project that we dealt with immediately near Ash Creek. The other projects, we've had, I think, approximately 14 projects that we've done throughout Bridgeport regarding the sewer separation. Now, most of the areas that we did this work, we took the existing combined line and we separated it into two phases. The first phase was to take the actual pipe and to line it. And once we lined it, the second phase would be then to install a completely separate stormwater system. And right now, I think we're approximately 75% done with doing these separation projects in the Bridgeport area. So, Adriana, you want to go with the next project?
Sure. Good morning. My name is Adriana Restrepo. I'll be the project manager for this project. I want to continue with some of the projects that we included in the proposal that were either by reference or included a full description of the project. So just a quick overview. The first one is a project we completed, the design for Suffolk County Department of Public Works. This is the extension of a 48-inch Interceptor sewer going under the Southern State Parkway. We did extensive investigation, geotechnical investigation, to make sure that the excavations at each end were watertight. We were going to provide information for microtunneling and completed several meetings with the New York State DOT and with Parks Department, which owns this area. So the approval was important to begin the project. We showed them basically a concept of what the project was going to be designed, and the additional investigation that we provided, and also the monitoring of the movement on the roadway, which was very important for them to consider in the volume of vehicular traffic on Southern State Parkway. So the other project we wanted to talk about is the Belgrade Water Pollution Control District. This project was to build a new effluent pump station to be able to replace this existing pipe that was supported on wood piles crossing a wetland area. So we completed soil investigation on this area, and had meetings for approval with the DEC and the Army Corps, and provided a directional drilling design for the installation of the new pipe. In the city of Camden in New Jersey, we've been doing reconstruction of sewer lines. So we dealt with regulatory permit approvals, a lot of utility coordination going through the city, and the replacement of the main and the sewer line. Some of the areas required active bypass there will also cross wetlands areas in this project. So what we're going to do also in this presentation is we're going to talk about a little bit of the scope of work as we understand it. We're going to cover what we reviewed during the proposal phase, what we suggest as the approach to the replacement of the pipe, and also the considerations as far as the site itself. So the scope of work is the replacement of this 33-inch reinforced concrete pipe with a new 36-inch pipe to cross the wetland area. Removal or abandoning existing pipes. We will be designing also support of the excavation, replacement of the wood piles, and the existing concrete weirs that belong to the drainage structure. So our plan for delivering the project is selected is we will initiate an investigation and an analysis of the information provided. We did a little bit with what we received during the proposal phase, but we will deeper into additional information that seems to be available for the area, including geotechnical borings and environmental sampling. Once this is completed, and if we determine that the information is sufficient to provide a concept plan, then we will proceed with the preliminary design, provide a concept plan with a cost estimate. Then we will proceed with additional investigation if we note that it's not enough for providing design, or if in meetings with the EEP, it's known that they will require additional sampling during the design phase. We will complete the topographic and utility survey of the area and provide an analysis of alternatives for the replacement of the pipe. In this analysis, we will include mitigation measures. We will include a cost estimate for the alternatives, any risk associated that we foresee in during construction, so that the town is aware of what each alternative entails, and to be able to make a decision on which one to follow through. Once a decision is made about the alternatives, then we will do a presentation to show you what the options are. We will proceed with a detailed design, about 30%, and provide a cost estimate with it. In this phase, now that we know what we'll follow, which alternative is going to be followed, we will initiate permits and discussions with all the agencies. In the final design phase, we will complete the drawings and the specifications, provide a cost estimate, and finalize the permit. We included a suggested schedule for delivery of the project. We consider it to be about 6 months from beginning to end. This will depend also on the meetings, the initial meetings with the agencies, what their requirements are about approvals, and any time that the town will require for reviews or presentations to the public, or any other aspects that are out of our control that are more for town or approval agencies. We will provide a presentation as here part of our schedule. So Hiran is going to provide now what we provided as far as the review and doing the proposal for the geotechnical and foundation aspects of relocating this pipe. Hiran? Hiran?
Okay, can you hear me?
Yes, I can hear you now. Sorry.
Okay, so it looks like, yeah, we have to unmute both the laptop and the phone. Okay, got it. Good morning, everyone. My name is Hiran Shah. I'm with Muser Rutledge Consulting Engineers. We will be the geotechnical and foundation engineer on the project. My background, I'm a senior associate at Muser Rutledge, a geotechnical engineer practicing for over 30 years in the Connecticut, New York, New Jersey area. I have been involved with a number of sewer replacement projects, both by trenchless and trench-laid methods, trench methods on piles, shallow foundations. As a firm, Muser Rutledge has been involved with a number of projects in the Fairfield and Bridgeport areas in the past. I'll give a brief overview of the existing information that we've looked at as part of the proposal phase, and then also provide a brief overview of the approach, the project approach that will be followed and the options that we will investigate. So on this first slide, I'd like to show the available information in terms of the geotechnical borings that were provided by the town. This particular plan on the left shows that in the vicinity of the sewer alignment, we have 2 borings close by, and one of the logs of one of the borings is also shown on the screen. Basically, what it shows is that the soil stratigraphy consists of a thin superficial fill layer about 5 to 6 feet thick, below which is about a 10-foot thick layer of organic clay marsh deposits, and then below the marsh deposits is a competent sand stratum. And that sand stratum would be a acceptable stratum for bearing of pile foundations for the sewer. Next slide, please. So this next slide shows a whole lot of additional borings that are available from the Metro Center drawings. We still don't have the logs for these borings, which I assume will become available as we get into the project. But this shows a number of soil borings, which are shown by the closed targets, the closed circle targets, solid circle targets. And in addition, there are soil samples, which are shown by the triangles, and also monitoring wells, which are shown by the open targets. So there's a lot of information available already in this area, which we'd make use of. And that is, our goal is to save money and not make additional geotechnical borings, but use this available information. And we believe it might be sufficient. We still have to look at some of these logs, which we don't have yet, as I mentioned, but we believe that may be sufficient. And if not, we would go in and recommend making additional borings. We also understand the construction of the existing sewer and the foundations as was depicted on this drawing that was provided by the town. This shows on the left-hand side a longitudinal profile of the sewer. 311 feet of the sewer is to be replaced, of which 176 feet is shown to be supported on timber pile foundations. A cross-section of the sewer with the pile foundation is shown on the right. It shows the 33-inch sewer supported on timber piles. There are about 22 bends of timber piles, as we understand from the drawing, and each bend consists of 2 timber piles, and the bends are spaced about 8 feet on centers. There is another drawing which is referenced on this drawing. If you can go back, Adriana, on the left-hand side profile, which we don't have yet. But if that drawing is made available, we believe it would show more details about the pile foundations, the lengths of the piles, the capacities of the piles. But if that drawing were not to be available, we still have, based on our experience, the pile capacity is likely to be 20 tons each. And based on the soil stratigraphy that we have from the couple of borings that we have logs for, we expect the piles to be on the order of 20 to 25 feet long below the bottom of the sewer. So we have a good idea of the existing sewer construction. Once we get onto the project, we will review all the available information, and then following that, we would, our initial investigation would include making test holes to determine the depth of the sewer pipe, to confirm the depth of the sewer pipe and the alignment of the sewer pipe. I'll talk a little bit about the proposed approach for the project. We plan to investigate two options, one of them being replacement of the sewer pipe in its current alignment. What that would involve is that, it would have a benefit of a reduced environmental impacts in that the embankment would not need to be expanded. What this option would entail is it would need a pump around, bypass flow while the construction for replacement is in progress. The assumption is that new pile foundations would be required, as is noted in the RFP. We would design the new pile foundations for the new sewer. We will also evaluate, in order to try and save some cost, construction costs to the town, because new pile foundations can be expensive, is to investigate the use of the existing piles after the sewer is removed to support the new sewer pipe. We have experience in reuse of timber piles on several projects, and that can certainly be a possibility to reuse the timber piles to save costs, so we will evaluate that. Nonetheless, the steps involved, right, for this option would be to excavate down to the top of the sewer, install a supportive excavation system. Of course, we will address the environmental nature of this site, given the information from the Metro Center drawings, and proceed, with the design and construction specifications accordingly. So the way we envision is that once the excavation is done to the top of the sewer, an excavation support system would be installed, the existing sewer pipe would be removed, new or reuse of the pile foundations would be made, followed by installation of the new sewer pipe, the 36-inch pipe, backfilling, and then replacing the pavement in the roadway areas and the soil surface in the other areas, and any environmental measures like reinstallation of the liner and the membranes, and then connection to the existing manholes would be done. So that's the first option of replacement of the sewer in its current alignment. The second option that will be investigated is the replacement of the sewer pipe in a parallel offset alignment, in which case there would be new manholes that would be needed to connect to the new alignment of the sewer pipe. Modifications to the existing embankment is likely to be required. And because the existing embankment may need to be expanded, it may entail additional environmental considerations. But the approach would be similar to the first option in that an excavation support system would be installed along the offset alignment. Excavation inside would be conducted while trying to minimize the groundwater inflow into the excavation, considering the environmental nature of this site, followed by installation of new pile foundations, the new sewer pipe, backfilling, putting the liner and the membranes back in place, and then finishing off the surface. So that's in general about the approach that we envision for the two options. I'll hand it back to Adriana to talk a little bit more about the environmental aspects.
Let me just jump in and let you know that we're down to about 3 minutes.
Okay, yeah, this is our last slide. So I just wanted to say that we understand and we have reviewed the concerns on this side as far as the environmental remediation that was completed previously. And we will have that into consideration with the new alignment. That's kind of one of our concerns with this last approach. And we will provide new manholes to connect to the existing. So depending on the exact location decided, it could be within the existing embankment or a modification of the embankment. So thank you for giving us the opportunity to present today. If you guys have any questions, we're open for questions.
I think the only question I have, Bill Norton, I'm the superintendent of the wastewater treatment facilities. On current projects, we've run into some soil analysis problems and contaminations. Can you speak to how you would handle any kind of remedial work that would be needed to do on the soils?
I did.
Computer and the phone.
No, I did. I'm good.
So we're gonna, like we said before, we're going to look into the information that's available for the soils in this area. But if additional is required, and then we're going to obviously include the requirements for the contractor to deal with the contaminated soils and the removal of the soils. We will provide a full protocol. We have a group in our we have a sub-consultant that's a licensed professional in Connecticut for the environmental remediation. And also we have an internal group that completes site remediation. So we will include all the specifications that are required for the contractor to remove the soil and dispose of appropriately.
Okay, thank you.
On a sidebar, if I can add also that sometimes groundwater remediation, right, and disposal can add a significant cost. So we have experience in design and construction of excavation support systems that would minimize the inflow of groundwater, we understand, which may be contaminated from entering the excavation, and therefore, minimize the volume that would need to be treated and disposed of. Mm-hmm. So we have experience with such excavation support systems, while not incurring large costs of the excavation support system.
Mm-hmm. That was completed for Carl's River because of requirements from the DEP to minimize the dewatering on those sites. So we did it a tight sheeting design to minimize to about 20 gallons per minute for the excavation.
Okay, thank you.
All right. Okay, so if there's any other questions, we're available. We thank you for this opportunity. Hello?
Hello. This is Bill Hurley from engineering. Just a quick question on Connecticut DEP, being that you're an out-of-state firm, although you've worked in Bridgeport and other parts. Are you familiar with all the DEP processes going for permits and timelines and all that?
Well, we've worked closely. We have worked with Connecticut DEEP with some of their environmental groups. We're very familiar with more with the sewer people in DEP, but we did some additional. Initially, when we did our original feasibility study, we did work with them. It's been a while, so. But we are familiar with the agency, and we can get involved with that. We do work closely in New York State with our DEP and DEC. So we're very familiar with environmental processes, and we do have an environmental group at D&D itself that work on permitting.
All right, thank you.
I don't know if you could hear me. I think I'm unmuted now. Laura Pooley?
Yeah, I can hear you, Laura.
Yeah, we can hear you.
All right. So I had some questions about the dewatering process, removal of any contaminated soils, because this site was remediated at one time when the Metro Center was built, as you're aware of. But would you just have a general in your design? Many engineers, they just say you have to dewater the site and leave it up to the contractor for the means and methods. We're finding that these dewatering systems are becoming very expensive and very complex and are triggering change orders that are very costly. Would you be able to give a detailed dewatering system and also how to handle the water that comes out of the dewatering system? Should it have contamination in it? I hope it doesn't, but in the same time, you're going to be dealing with the DEP for restoring tidal wetlands that are going to be destroyed, and that is going to also have to be shown somewhere. So there's a lot of DEP requirements that will apply to this, and my concern is the dewatering and the sewer bypass during construction. I was part of this project when they did construct it, and they did install a new sewer line, and they had issues, just so you know, with the bypass that was used. Even though they had adequate pumps, they thought the flows were fine, but little did they know way upstream in the east trunk line, it was bypassing at a very low point. So that has to be looked at very carefully as well, the method of the sewer bypass for this.
Here, part of the dewatering again. Hiran kind of
yeah, sure.
Dewatering system. Mm-hmm.
Yeah, I mean, I touch again upon we have experience with designs of excavation support systems that will minimize the groundwater inflows into the excavation just by looking at the preliminary soils information that we have here. This site should have a very good favorable stratigraphy in the sense that the excavation support system that can be installed is an interlocking steel sheet pile system, if needed, with an interlock sealant that provides virtually a groundwater cutoff, both from the sides and from the base, because that organic marsh deposits is a very good aquiclude, so it prevents water from coming up on the bottom. And together with the interlock steel sheeting system, we would say that the flows would be virtually, if I were to guess at this point, very little, like 5 GPM or less, and that can be handled by virtue of sump pumping. An elaborate well point system is not likely to be required. A sump pump dewatering system should be adequate, and then that very little flow that comes in. I'll let Adriana address, like the dewatering treatment system that would then handle that flow, and then the treated effluent would then be discharged appropriately, right, Adriana?
Yes, correct. Yeah. So we had like a similar issue with the project that I was talking about on the extension of the Interceptor. And this project, because it's sands, actually we're providing a thick plug on the bottom, a concrete plug, as well as tie sheeting. So all of that was provided in our design document. to ensure that, because the DEC had a specific requirements on the limit of the flow coming into the excavation. So we provided the design and provided also a condition in the documents for the contractor to comply with the tight sheeting. So that one required jet grouting because we sand, but he had a provision that if the contractor wasn't able to keep basically the excavation dry, he will have to remediate, meaning come back and do more grouting if necessary. So we have it in place. That's being dealt with before. We have experience.
All right, and then the dewatered may not be able to go into the sanitary sewer line, depending on what the constituents are in the water. So we have a project going on now, and due to what's in the groundwater or could get in the sediment, it's not allowed to go into the sanitary sewer line. So I don't know if that's the same case with this project that you're working on, but these are concerns that we do have with this project because it was a contaminated site.
Yeah, so depending on, so we will look at the information. Well,
hey guys, sorry to interrupt. This is Corinne Dyer from the purchasing department, and we need to wrap it up because we actually have another call coming in at the moment.
Yeah.
Okay. Yeah, I guess to conclude, we will, we will provide instructions for the contractor to treat it on site and dispose off site. Since he can't be discharging it into the sewer system. So a meeting with the DEC early in the design is what we intend to have.
Great.
Thank
Thanks
you.
very much.
Thank you.
Thank you.
So,
Corinne?
Yes, I'm here. Sorry about that. So I just want to thank everyone. No, you're fine. I just want to thank everyone for calling in, and we're actually going to go straight into our next meeting. I know this is a little awkward. I apologize. So thank you very much for meeting with us today. And I would just ask that everyone that's not a town employee just, log off, and we're going to go straight into our 10:45 meeting.
Okay.
Sure. Thank you.
All right.
Nice
Thank you very much.
Everyone. Take care.
Okay. It's Mark Ellison from WPCA. Chris, sorry to jump in.
No, it's fine.
The next group is BL, and I would strongly encourage you guys to do the presentation, but leave some adequate time for Q&A. That would be greatly appreciated. Thank you.
Certainly.
Chris, do you want to do like a quick overview as you did last time? Just introduce.
Yeah, I'll give you a quick overview. No problem.
Perfect, thank you.
So as you're aware, the project entails replacing the 33-inch line through the wetlands to increase it to 36-inch. It's approximately 311 feet through the wetland area. The pipe is currently on wood piles. We need to determine if those piles are still in good shape. They probably need to be replaced. There is potentially contaminated soils in that area. Part of the project does entail a capped area with a rubber membrane, and there will be a lot of permitting and whatnot on this project. So from there, I'll hand it over to BL for your presentation.
All right. Thank you, Chris. I think we're waiting for one more member of our team calling in. I think she's calling in now.
And I'm going to share the screen, Nick, here so we get the PowerPoint up.
Perfect.
Hi, Nick. It's Laura Pooley.
Hey, Laura. How you doing?
Good. How are you?
Good. Loving this new environment, huh?
Yeah. Yep.
First time I had a jacket and tie on in about a month.
Yeah.
Oh, yeah.
Well, you look nice.
Thank you. No,
Hey,
Michelle
Nick,
has joined.
Nick, it's Bill Hurley, and I owe you an email, but I did get your email, just to let you know, on another project.
Okay, yeah, no problem, Bill. Just I know it's the end of year stuff too. Just to catch up.
Yep.
No big deal.
Sure, thanks. All's good though.
Good, excellent. Well, we might as well get going. If Michelle is able to join us during the presentation, that'd be great.
Yeah.
She does have some sewer experience, and she is our quality control rep. We might as well get started. Matt, is the view going to be the full screen or the preview? I'm not sure how you have that set up.
Did I switch that on? So do you have the preview screen right now? I apologize.
Yeah, yep.
How about now? Do you have the right screen now?
There we go. It just went back and forth.
Oh, good. I was hoping it would do that. All right.
There we go.
How about now?
Did it again.
Whoa.
No. There we go. I think that's right.
We're up. We're running. We got it good together. We'll figure this out.
Yeah. There's just a small little gray screen in the upper right corner of the presentation. I'm seeing. Other than that, it looks good.
How about now? Okay.
That works.
That's just our faces. Oops, sorry.
Yep.
All right. All set.
All right. 2 minutes in. Well, thank you all for having us. We're very excited to be here. Love working with the town of Fairfield. I know myself and Jess have had some personal experience with the town, and we'd love to work on this project with you because it is an interesting project to say the least. Next slide, Matt.
Oh, sorry. Yeah.
So quick introductions. I'm Nick Giardina, the director in charge of this project. I got over 30 years experience in infrastructure design, especially on the public side. I have a direct experience at the Fairfield Metro Center, my previous engagement with another consulting firm, and working directly for the state DOT. That's where my experience of this area comes in. We do have Michelle Carlson on board for quality control, quality assurance. She also has over 30 years experience and over 15 of that working directly on sanitary sewer projects. And I'll let Matt and Jess introduce themselves.
Yeah, hello, my name is Matt Robillard. I'll be the project manager on this project, which means I will be your primary point of contact. And I have just about 10 years experience with sanitary sewer projects as well as other infrastructure.
Hi, my name is Jessica Bates. I'm a professional engineer here in Connecticut. I have over 20 years experience, and I do have experience from my previous life working with the Fairfield Metro project in and of, by itself.
Oh, sorry.
Great. So a quick agenda of what we'll talk about on this, and we do want to get to the questions and answers. I know it's an important part of today's meeting, but we'll give a quick overview and introduce the project team, which we're already into. We'll touch on our local experience and knowledge of the area, and then we'll dig into the project understanding, which Chris just touched on a bit, and we'll go through our approach and the constructability aspects that we could see on this with our the due diligence that we've done so far. And then, of course, part 4 would be our question and answers.
There we go.
So as you know, and we are working with the town on a couple of other projects. We were founded in '86. We have over 200 Connecticut-based employees with offices in Meriden and Hartford, Connecticut. We are working mostly, all of us, from home now, so we got almost 200 offices in Connecticut. We are 100% employee-owned, and we have a diverse set of public and private clients. So you may have seen us on the land development side of things as well as on the public infrastructure side. So this quick snapshot of our organizational structure. Everything will go through Matt Robillard, our project manager. He'll be our single point of contact. And as I said before, I'm the director in charge. My name's Nick Giardina again. Michelle's our quality control rep. And I'll have Matt touch on a couple other key folks on our organizational chart. And then dig into the approach.
Yeah, thanks, Nick. Again, my name is Matt Robillard. I am supported by Michelle Carlson on the quality control, quality assurance, who does have over 35 years of experience. I will highlight I am a PE as well. It's left off this org chart here for some reason on accident, little typo. I I like to highlight our geotechnical consultant. We do have Down to Earth Geotech Consulting on board. They're going to be doing the soil borings as well as pile design as needed. And I'd like to also bring to attention Davison Environmental. Eric Davison has significant experience in Fairfield in this location, as well as permitting this type of work. So he will be our environmental and wetlands sub-consultant. Additional kind of added service benefit here at BL is that we do have our construction administration and construction folks on board, typically early in design as part of the design, and that will be supported by Adam DeWitowitz. We know this project is, constructability is a key concern in this project and impact. So, having him involved early in design, throughout the design to kind of review and provide comments will help us as the designers to provide a better constructible design, more feasible design, not issuing something that could come up to be a problem during construction. So let's talk a little bit. Nick mentioned we do have some local area experience right in this location. Nick and Jess were both team members for the Fairfield Metro Center. Jess was involved frequently visiting the site during construction as well as some design. Nick involved on the state side. So we do know the area very well. Our survey team actually was working on an Belgrade UI project right in this location, so we've got some familiar experience there. And as you know, right up the creek there, we have working with the city of Bridgeport on the pedestrian bridge for Ash Creek Pedestrian Bridge. So we do have some coordination between the town with yourselves and with the city of Bridgeport. So we know Ash Creek, we know what it takes to permit impacts in Ash Creek, and we do know the area. I won't spend too much time on this slide. You did it for me earlier today, and that'll leave a little more time for QA/QC. So as you mentioned, it is 311 feet of concrete pipe, replacing it, sitting on wood piles to be evaluated. Likely, new piles will need to be installed based on their life and the usual service life of a wood pile. We do also have, I don't think you mentioned this, but there is the replacement of the concrete weir. Due to the construction of this sanitary line, the replacement of this concrete weir is to be included as part of our project. And that kind of folds over into our approach. So there's a lot of information on the sheet, and there's a lot of information on this project. So I'm going to keep it high level now and love to dig the details during Q&A. So generally speaking, our approach to this project is to gather out all the existing information, go through the existing reports. We know that the town is looking at upgrading the trunk lines in this area as well. So we just want to look at the flow monitoring data, the flow data we do have, and kind of dig in to make sure we have everything we need to confirm that 36 inches is the adequate capacity. And once we have all the information, one item we really like to highlight is our early permitting coordination. Permitting on this project is going to be extensive. We know that, as you see down there, we've identified all the different permits. You have CTDEP, LWRD, tidal wetlands, floodplain, the Army Corps, Local Conservation Commission, Coast Guard, WPCA. There's a lot of coordination that needs to happen, and we firmly believe that coordinating early, having some early meetings, getting out ahead of that is going to help expedite these permits and provide us with the shortest lead time in order to get this project constructed and permitted. From a geotechnical standpoint, we would have some geotechnical borings on both sides of the sanitary line. We need to evaluate the soil types to confirm for pile design. And then we also need to, while doing that, do some environmental testing. You mentioned it. This site potentially is contaminated, very likely. We know previously on the Metro Center we had the casting sands and the PCBs. We know there's like a liner. There's a lot of concerns from an environmental standpoint. We have the staff in-house at BL Companies to do those testings, and that's a service we do provide and we will provide for this project. We want to look at the pile type. That's something that we see as something we want to get out ahead of early, understanding if we need to replace the piles, what the condition is. If we can't determine their condition, we would probably likely suggest replacement of them. We would say that you have the option to replace them with the standard wood piles like there are existing now. It's an economic option. There's also the option to evaluate different materials, whether we're looking for longer service life or we're looking for economy here. That's something we'd work with the town to determine. Same thing with the sewer design. So we're looking at this pipe. We know that it is existing concrete, but this material, this pipe is going to be exposed on some level to tidal waters, salt water, corrosive material. So looking at the type of material we use or if a protective coating is necessary, We're trying to make sure we extend the service life to the maximum extent feasible. Let's look, also looking at this concrete weir, we have to look at how we approach replacing this concrete weir, whether it's through a sequencing, how we handle the water handling. Really important is that this concrete weir is holding back water, retaining water in order to create a wetland. So we need to make sure the wetlands stay wet. That's our key approach here. We need to make sure that we're protecting the wetlands. I know that's going to be a concern of the Conservation Commission. So we're going to look at that, whether it's a staged approach using the lane configuration, whether it's using sheet pile cofferdams, trench boxes. These are things that we're going to evaluate and appropriately design for construction. I mentioned permitting. We do have the tidal wetlands permit, the floodplain permit, Section 404, local conservation commission, U.S. Coast Guard coordination because it's considered navigable, and also coordination with the WPCA. DL companies here, we believe communication is key. We understand that we have to communicate with all the stakeholders, from utility companies to any property impacts to all of the permitting agencies. On this type of work, getting early communication and often communication is going to be our priority. So with that being said, we also looked at some constructability points of this. So we know that constructability is going to be a challenge based on this pipe, right? This is a tidal crossing. There's a concrete weir. There's wetlands. So there's some things that we identified that we're starting to look at. We know site access is not an issue, but site access identification points. So we do know that in order to get to the other side of this pipe off of Kenwood, best suited access point would likely be off Ash Creek Boulevard. There's some private land in the middle between, and then there's conservation area as there's a pathway to get to this crossing. Our plan would be to minimize any impacts to this conservation area. If we could look at potentially crossing through the private property, that's one option. Another option would be to utilize the existing pathway that's in the conservation area and then minimizing our footprint and restoring as needed. But that's something we're considering, we're looking at. Another thing we need to look at is material storage. If we're pulling out material that's contaminated, we're going to have to find some place to store it, whether it's on site, which would need to be on the right-of-way, town right-of-way, or if it's off-site, we also need to make sure it's out of the floodplain if it's on-site. So it's a concern. It's something we're thinking about. We're trying to come up with solutions, and we're going to come up with solutions before it goes to construction. Anytime you're talking about bypass pumping, we have to be concerned about sizing the bypass pump. Also have to look at wet and dry conditions. But more importantly, making sure that when that pump, making sure we have a contingency plan for that pump failure. That's not going to be an option here. We need to make sure that pumps don't fail, and if they do, we need to make sure we have an appropriate plan in place. We talked briefly, I mentioned the water handling. Again, looking at how we can appropriately stage this construction and sequence this construction in order to handle the water appropriately, to keep the wetlands wet, to reduce any tidal impacts to those wetlands, to protect the construction, protect people during construction, all of what we're looking at and part of our process. So with that being said, also, we want to look at restoring this back to the condition it was in before we left it. So with that being said, we kept the presentation brief. We're happy to welcome any questions, any comments, and love to kind of dig into this project with you.
Thanks, Matt.
Well, it's Laura Pooley. I'm glad Nick is on your team because he was there when this was built and I think knows the history and the type of contamination involved, and I'm sure you'd still continue to investigate further, but you did touch on a lot of issues that I'm concerned about is the constructability and where you would stage your pile driver, when you do go to put in piles to support the line. I mean, that's going to be more of an impact on the wetlands, tidal wetlands, and the estuarine embayment area as well. So, and that's going to have to be a substantial roadway bed to hold this piece of equipment to drive the piles, and any steel sheeting that you're going to use for cofferdams. So access, I think, is important, and where you're going to store this the material that's contaminated, whether it's on site, I don't know where on site that would happen, but you did touch on many of the obstacles to get this done. So that's all good. That's my comment, that you did address many things that I'm concerned about.
Great. Thanks, Lori. It's hard to believe it's 10 years already.
10 years, yeah. And just so you know, there is a plan. People do want to build apartments there, and, it did go before zoning, so I don't know how the access is going to be through the private property. They may say no. You might have to go to Conservation Board and ask for permission.
Yeah.
And that may be difficult, or just use Kennard and Kenwood over there on the west side.
And we did talk to our geotechnical sub-consultant on this and discussed, kind of the staging. He feels that they do feel that they will need to set up on, on both sides due to the size of the crane that would be needed in order to drive the piles. They don't have enough span in order to just do it all from Kenwood. So we're going to have to address that. We're going to have to look at asking the Conservation Commission or looking to gain access to that private property, which may be the better option if they're open to it. Right now, there is no development there. So, we are looking at that. But Geotechnical Down to Earth did say that driving from both sides. They also did mention that you could potentially use 3 setups with a smaller crane. So you may not have to bring in such a large piece of equipment. And, you could put an intermediate setup in between. But that's a bit more permitting from a temporary impacts to have, a barge out there to install those. It's probably a bit more expensive as well. But it would reduce the size of the equipment, which may make it a little bit more. We have to kind of look into exactly what equipment will be needed. But if that impact is smaller on the conservation side, they may appreciate that, right? So there's going to be a balance. There's going to be a give and take on where we find, where we can impact versus where we cannot.
Okay. How long do you think, based on all the permits that are required from Connecticut Deep and everybody, the town, this is going to take to get permitted?
We talked to our permitting guru in-house, and he believes since almost all the permits that we'd be looking for are temporary impacts, he sees it almost as like a 6 to 8 month duration to apply and get everything approved.
All right. What about reopening the cap there? Don't we have casting sands in that area? Don't you have to apply, because that's got a wrap over it, and doesn't that have to be reopened and conducted under an LEP in that area?
Or you're talking about the Metro Center?
I'm talking about where you're crossing. Because as part of the package, there was that sheet 79, the remediation, approximate limits of soil and fill requiring remediation. In this area, it does show that it's got casting sands there.
Yeah, we're running into that with our Bridgeport Ash Creek crossing as well, where we do have to puncture the cap, but it is a process. I'm not exactly sure how long that would take, but we certainly are aware of it and would need to go.
Okay, I didn't know how long that took to actually for them to review. I know that they don't move very fast.
Yep.
So, all right. Thank you.
Yeah, one comment I wanted to make was there's a large UI easement through that property. I don't know what the feasibility is with the crane and the pile driver and so forth. Yeah. So that would have to be something that would have to be looked into. So.
Absolutely. We were kind of looking at conceptually, at least on Google Earth as well, and it looked like it should be outside the clearance envelope for any pile drivers. But again, obviously you got to keep that in mind when working around any kind of those power lines for sure.
And
we'll look to avoid any outages.
Yeah, we did look at that, like Nick mentioned, but we also do have information on those easements currently as well, since we were working with UI on that project. So we do understand exactly where that is. We have clearances. We have some intel onto exact information on wire heights. Our survey for that, it did include understanding, they got all the survey for there, so for the wire. So we do understand how much clearance we do have. We have a great working relationship with them as well. That's something else that comes out of our relationship working with Avangrid and UI, is that our ability to work inside of that easement may be, that's a benefit that BL does have, is we're able to work closely with them based on our existing relationships. But again, it all comes down to the size of the equipment we have to bring in. So I think that there's a balance understanding, are we bringing in one large piece of equipment, or are we bringing in, smaller equipment and doing multiple setups? We'll have to evaluate that for sure, but it is something we're looking at.
Good.
One other question.
Okay, go ahead.
Real quick. Do you foresee the DEP requiring us to do that 3-to-1 wetland mitigation here?
I don't, because it's a temporary impact, Laura. But yeah, we certainly would confirm that. You know, we would just be replacing back with whatever's disturbed.
Right. But I think you probably know that every time you disturb 1 square foot, you've got to put 3 back because they don't think 2 of them are going to survive. So you'll end up with 1. So I'm just, you know, all the projects that we've worked on the past couple of years, that's been the requirement. It's just something
Jess, do you have anything
to think
to add
about
to that?
where we would do that.
Mm-hmm.
If that were to be the case, I think we would have to look at possibly moving the weir out closer to the Ash Creek to try to get that square footage in the estuary part of the wetlands, since that's what would be affected. The freshwater wetland that's on the other side of the pedestrian crossing would be safe still. So if that were to be the case, even though it is a temporary condition, it is something that we'd be putting back. You know, we would go in with, you know, we're putting back the wetlands. We would, you know, remove any invasives that could have taken root in the last 9 years since it was created and whatever. And if they did end up having to, you know, require us to do any sort of recreation, you know, we're kind of, we're hemmed in on both sides, east and west, so we would have to just go south towards the creek itself and change the crossing to move it down, which could be easier for constructability because then we could construct offline and we could leave the old pipe in place and just build the new pipe and tie in and only have to deal with the bypass pumping for a shorter period of time. So it would bring something to the place, but it would, you know, it would be a you know, a balance of trying to get everything to work out well. But that would be my initial thought. Would, you know, we would have to go in that area to the south.
Okay.
Something we could address early on too, Laura, is to when we have our meetings with the local commissions and everything, we could figure that right out. Get it up, you know, get all those details worked out before we create a design and then go bring up, you know, a plan to them and then ask us to do 3-to-1, right? So I think that's an important aspect of us doing it early coordination with them.
Yeah, definitely try to get in front of the deep, you know, for pre-project, you know, review.
So, Jessica, you worked on the Metro Center too, right? I haven't seen you in ages. Hi.
Hi.
How are you? I don't have a camera, so it's good to see you.
So that was with TV, right? Or different one?
Yes, I was with TV back in those days.
Yeah.
Any more, Laura, or are you good?
No.
Okay. I had this Bill Hurley from engineering. I just want to know if you have any quick conceptual previews or any suggestions maybe for initial cost savings or how to avoid extra costs or change orders. I don't know if you had a chance to take a look or have any preliminary ideas.
So definitely one of the first things we consider from a cost savings would be to evaluate the pipe material, right? So we've considered, you know, if you're using concrete versus some other type of pipe material, that would be one option, as well as when we design the piles, we can look at, you know, appropriate cost savings from the pile type, not, you know, utilizing the appropriate pile type, not using steel if we only need wood, right? That's one initial concern, one thing we definitely looked at initially. Nick or Jess, do you have anything else that you could add to what we think we could save some additional costs here?
It's one of those things that
sorry.
Go ahead, Jess.
No, you go, Nick.
Yeah, I mean, one of the things that we have at our advantage is we know a lot of the unknowns, which are typically come up with a project like this. And knowing most all the unknowns will certainly help with regards to avoiding change orders when it does go to construction. So, you know, the more due diligence and the more engineering you do to find out exactly what's out there, the more you could prepare for it when it does get to construction.
Yeah, I mean, initially, my natural inclination is to go to stormwater because it's such a large part of this. You have the 6x4 box, that outlet that comes under the tracks up by the station itself. So this whole wetland system is fed by that primarily. So, you know, we would probably try to look to not bypass pump that because it is such an influx of water, but do something more with possibly like an open like lane configuration, like build half open it up, build half, the other half, open it up, and modify that weir to keep the wetlands wet, to keep, the systems functioning as they're supposed to, but to still allow the water to go out without having to actually pump the water or something like that. So if you did get a larger storm, it could pass naturally, and, you'd just be dealing with the after effects of the stormwater. So that was kind of something that I was naturally kind of, running through in my mind as I was thinking about this, bypass pumping of the stormwater, modifying the weir to let the water pass and things like that. So that was kind of my first gut, but I kind of go to drainage first because I'm a drainage nerd.
Now, would that help on dewatering, or that's just keeping, like you said, the wetlands wet, and dewatering is completely something different? The trench or...
Yeah, groundwater dewatering would probably be separate from that. Like, due to the elevations, you would have to pump that because, the pipe is, well, the old plans were negative, 1, which was on the, 29 datum. So, dewatering for the groundwater would have to be pumped. I don't think there's any way to get out away from that. But just the surface discharge from stormwater was really what I was thinking about.
Mm-hmm.
All right, thank you.
Yeah, I think minimal bypass pumping is the best. If you could not pump the stormwater and just let that flow naturally, and because we're going to be dealing with bypass pumping the sanitary line, and we know what happened last time at that site. It was not pretty. So,
no.
Don't want that to happen again.
And just to let you guys know, I've been talking. Michelle Carlson text messaged me on the side while we were presenting, and she said she was trying to get in, but she was unable to enter the room. So she apologizes for not showing up. She tried multiple times with multiple electronic devices, but she was not able to make it in. So she apologizes greatly for that.
I think she was on earlier, wasn't she? I thought I saw her. No?
I don't know if she was able to get the video to work, but she couldn't get the audio to do it. So she was.
I saw her name pop up.
She was experiencing technical difficulties with the audio versus the video portion of it.
And that causes a panic, let me tell you, when you can't get on.
Yes.
Hey, guys.
Yeah, we'll experience that.
Yeah, I wanted to ask, it looked like we had a couple minutes. Let me ask a question because I wasn't associated with this. And I'm Mark Ellison, I'm on the commission. Why wasn't this pipe addressed and replaced back when you all worked on it the first time around?
Could I answer that?
Please.
Because the reason why it wasn't replaced is because the pipe was sized adequately through the site. The 30-inch size or whatever size it is at the time was sized adequately. They changed the size where it is currently 36 through the Metro Center because they had to replace it to go around the area where the buildings were going to be built. And the idea was let's oversize it where in the future they could line it to get it back to the 30-inch should it ever need to be replaced. So that's why it was oversized. The intention was always to keep it 30 inches in diameter, never to enlarge it. If that was the case, then, yeah, the whole thing would have been enlarged right through the site. So they just did that one section through the actual area where the office buildings were going to be built. And they met up with, once they got around to the back of the building on the west side, they tied into the existing storm sewer line where across the wetlands there, and everything was fine. So
Lord, they didn't video scope the pipe at the time?
I don't know if they video scoped that pipe through there at the time.
Gotcha.
Maybe Nick knows, but I don't know if it was done at the time. They did video the 24-inch coming through the site because they were doing pile driving. They did micro piles. They videoed that. But a good portion of it was getting replaced because they were going to put the 36-inch in lieu of the 30-inch for the bypass around the buildings. I don't know if Nick, if you remember, if they videoed through under the wetland. They may have, because during construction they may have done some work. You know, they were doing work on that weir, and maybe they didn't want excavating, and they didn't want any damage to it. I don't recall for certain whether it was done or not.
Yeah, I remember the piece and the section of sewer pipe that was videotaped was north of the site and north of the tracks, because there was a couple of lines that had to be jacked under the tracks, and those were damaged. So that's the area that I recall being videoed. I don't recall if this section was videoed or not.
Yeah, I don't think it was. All right.
Excellent presentation. Thank you.
Thank you, Bart.
Thank you, guys.
Okay, thank you very much again. It's good to see everybody, even if it is in a remote world, and hope you all have a great holiday season, and stay safe out there. Thank you very much.
Thank you. Thank you.
Bye.
Bye.
Hey everyone, it's Corinne. So we have about 13 minutes until the next one. If anyone wants to take a break, I'll stay on just so, because I saw Joe from Cardinal log on earlier and then log out. I'll keep mine open in case he comes back. But yeah, just regroup at 11:30. And you can leave your room open. Just it's easier.
Yeah. I'm gonna mute everybody for the time being. So.
Okay.
Phone message. I'm glad those days are over.
The lost missing package.
March of 2020.
We're going to get Cindy and Warren. What did we talking about?
Okay, thank you.
Yep. Now, you have Warren's cell phone, you call him up and see if
he gets on.
And Cindy.
Yeah, I'm sure.
With Sharon?
Yep.
So his audio comes through there? I mean.
Chris?
Yes.
You could hear me?
Yeah, I can hear you.
Oh, good. All right, good. Don't need to tie up the phone. All right, I'll be right back. Still got me as a camera.
Nice.
Nice Christmas, Chris.
You just installed it right now?
No, just come in.
That's funny.
Do you think Cindy's calling in or what?
Joe, can you hear me?
Yes, I can hear you. Can you can hear me?
Yep, you're all set. Great.
Yep.
All right, I have one or two other people that are going to try to phone in from home.
Yeah, no problem.
Unfortunately, we got two people quarantined. They're not able to come in the office today, and we also have Cindy Knight, who's in Vernon. She'll be calling in from her office, hopefully.
Great.
Cindy Knight from Logical Environmental. So hopefully that works out. And I think we're supposed to be using our phones?
Yep, you can.
I'm on my phone. I think some people are on the WebEx, right, Chris?
Yeah, Joe, if you use the phone, it's for the audio, so we can hear you through your computer. So as long as it's working, you're good. So.
I think we're on phone, right, Jessica?
Yes, audio here.
We're on hardline phone here,
right.
And we're on the WebEx. So hopefully you're only hearing me once.
Yeah.
So, and so like I said, a couple of people weren't able to make it. So my father is here, Joe Sermola Sr., so he may be participating as well. So can we wait a couple minutes, see if the other two can phone in?
Absolutely.
1 or 2 minutes?
Yep.
Okay. And I assume we're going to focus on the project and not really go through any experience until maybe at the end if there's questions or if there's extra time. Does that agree with what everybody's expecting? Is there a reason to go through experience?
Chris, I don't think so. I mean, we have their submission, correct?
No, I mean,
unless it's
if you
directly
want to briefly
related.
touch on your past, if you want to briefly touch on your past experience for a similar project, it might be beneficial. But.
All right. Well, maybe I'll touch lightly on a few projects that are similar. But I'll go through it quickly, and if you have follow-up questions, we could go into more detail.
Who is the next group? Is it Cardinal?
Yeah.
Yeah, Cardinal Engineering.
Cardinal, 11:30. Okay.
Hey, Chris or Al, can you guys hear me?
Yeah, we can hear you.
All right, because for some reason, it's really low volume here.
Oh, you sound pretty clear.
Okay, good. Thanks.
He's trying to connect, I guess.
And interviews.
Cindy, are you in? Cindy just signed in. Can you guys hear her? There she is. Cindy, can you hear us?
She's muted. She has to unmute herself. There she goes. There it is.
Are you on your phone line, Cindy?
Hold it.
Warren? No, Cindy's still can't hear Cindy. Just call her on her cell phone. And...
Yeah, we can hear her. Joe?
I can't hear Cindy.
Cindy, can you hear us? She's muted.
I can hear you.
Yep, she can hear us.
There you go.
Yep.
All right.
Hallelujah. Warren's calling in a minute.
Warren basically is calling in from home. So Warren was the project engineer on the project that we just completed last year, downstream of this project. So he should be calling in any minute now. Is that correct?
Yes. But are you waiting or?
You want me to? I could get started in the meantime, though, if you want. Can you all see? I'm sharing a PowerPoint. Can you all see it?
Yes.
Mm-hmm.
Okay. All right. Well, I'll start out just a brief overview of Cardinal Engineering. I'll touch on a couple of our projects that have similarities to this job, and then we'll go into looking at a little more detail about the crossing, the wetland crossing area. Cardinal was founded in 1962, and we've been working exclusively with municipalities for 58 years. And for a lot of that period, sanitary sewer or wastewater collection systems were 70–80% of our work. So we've done hundreds of miles of sanitary storm sewers and very difficult projects similar to this. We are on-call engineers, and for the Greater New Haven WPCA, and we've been working in New Haven since the 70s, and Middletown and Cromwell Sewer Department since early 1980s. We do have experience in all the we have specialized experience in the projects. We've done sanitary and storm sewers on pile foundations. We've done work with handling contaminated soils and groundwater, bypass pumping, coffer dams, environmental permits. We've done waste and wetland restoration. We just recently did a wetland restoration project up in Stafford in association with the Bridge Project. Now, as far as I'm pretty much going through the RFP and the key points that they want us to focus on. Technical competence. I'll show you our org chart in a minute, but most of our people have over 25 years experience. We have experience in all the civil engineering disciplines, hydraulics, structural, civil, construction, inspection. And for this job, these are the three major sub-consultants. Logical environmental will be taking care of the contaminated soil issues. Soil Science Environmental Service is a wetland biologist firm that will be helping with the wetland restoration. And Clarence Welty will be providing geotechnical engineering. As you know, we just recently completed the East Trunk Sewer Relocation Project between Kenwood and Route 1. The other thing I want to mention, we've been very successful working on municipal projects over the past almost 60 years. 99% of our projects are within budget by the time the bids come in and by the time construction is completed. This is the org chart. I'll be principal in charge. Gary Giroux is one of our quarantine people. He'll be the project manager. Val Zorka is our hydraulic engineer. We have in-house surveying. Tim Cruz is our chief structural engineer. Roy Seeley is our senior civil engineer. He'll be project engineer for this project. Dave Foley is our chief resident engineer, and he'll be involved during construction. And as I mentioned, the sub-consultants listed below. As I mentioned, there were 200 major sewer and storm projects over the years. One of the biggest jobs is a citywide CSO facility plan for the city of New Haven with 100 miles of storm sewers. We've also designed quite a few of the CSO projects, the large Interceptor sewers in downtown New Haven, up to 108-inch diameter pipes. We've done townwide sewer extensions in East Haven, Cromwell, and Wolcott. Most of these jobs involved Interceptor sewers, and some of them on piles. We've done a citywide combined sewer separation program in Middletown with about 6 or 8 miles of new storm sewers and 6 or 8 miles of sewer replacement, 16 projects, and we just completed the last project over the last 20 years. As I mentioned, sewer extensions in East Haven and Wolcott, major sewer rehab projects townwide in Berlin, Cromwell, and East Haven. And most of our projects, sewer projects, have involved DEP and before that EPA funding. So we're very familiar with DEP requirements on these projects. This is just to give an example of what our capabilities are. These are the projects we've completed in the last 5 or 6 years. Your project is number one on the list up there, the East Interceptor replacement. We also did a trunk sewer rehab in Berlin, a 3-mile rehab of a 24 to 36-inch pipe, mostly through floodplain and an area where bypass pumping is required. Wetland restoration and protection was a key issue on that project. Mattabasset regionalization, we provided resident engineering for a 3-mile force main up to 30-inch diameter and a major 25 MGD pump station. And there's several other projects, and not going to go through all of them, but these are just an example of our capabilities, the amount of work we can get done in a short period of time. This is your project. Obviously, we're very familiar with the wetland crossing because we've done a lot of research. We have a lot of the materials from the Metro Center project. We're aware of the key issues, so I'll go into that in a little more detail in a minute, but we are intimately familiar with the project. One of the major concerns on your project is going to be handling the contaminated materials and groundwater. This example some of the recent projects where we've dealt with these concerns. The Mattabasset Regional Pump Station project included 2 miles of force main, and much of that area was in an area of environmental concern, where we had to establish a waste stockpile area and a groundwater treatment facility. Waterfront Street in New Haven, 2,000 feet of 24-inch pipe. It's located right next to the oil terminals. So that was another one of our projects with these kind of concerns. Great Brook Culvert, replacement Waterbury, West Main Street Bridge in Bergen also had an issue, and Logical was our sub-consultant on those, and we've done other projects with similar issues. I mentioned the Berlin Interceptor. We lined a 36 to 42-inch interceptor in Berlin, about 4 miles of pipe altogether, and bypass pumping was a key component of that project, and as you can see, these are the pumps that were provided for that project. They were pumping 12 MGD, or a capacity to handle a storm flood with 12 MGD capacity, the 18-inch force main. And that, of course, was along the Mattabasset River through an area of wetlands where it's very sensitive, also vernal pools in the area, so Warren was very involved in getting the permits for that project. Pile-supported projects, here's a list of some of the projects that involve pile foundations. This one here is New Haven. This is the Sherman Parkway Interceptor. It's a 96 to 102-inch storm interceptor. It goes through an area of peat and organic silt. It's in the sort of in the area of Hill House High School, if people are familiar with that. We installed basically a cofferdam but sheeting, drove timber piles, and then poured a concrete cradle along the entire length, and then set the pipe. And the 24-inch sewer was also on piles adjacent to that. It's another project in East Haven, a Riverside Interceptor, is also on piles. Just a real brief summary of some of our relevant experience. If you have any questions, we could go into that later. But to focus on your project, as I mentioned, we're pretty familiar with the job already. There is a little more research we want to do and obtain a little more information, and I'll talk about that in a minute. But we have a good understanding of the key issues here. It's a 33-inch pipe. It's located within that conservation area. The plan is to replace the pipe with a 36-inch. Present flows 2 to 4 MGD, or the daily flows. The wet weather flow, according to the previous hydraulic report, could be as high as 11 MGD. Sewers located within conservation area. There are contaminated soils. I'm aware that there was remediation done as part of the Metro Center project. It's my understanding that they excavated everything up to this pipe down to elevation 0, which is basically the bottom of the pipe. So our understanding is possible that the only contaminated soils left in the area are right around the pipe. But that's something we'll have to find out during our subsurface exploration. We're aware there's a ELUR, a land use restriction on the property. I don't know if that's formalized yet, but I know it's in the works. Cindy Knight has experience in that, getting the authorizations to do the work within these areas, so she'll be handling that for us. We know there's poor soil conditions, and that's why the piles on pier, one of the reasons the piles on sewers on piles. So the key issues, I think, finding out the extent of the contaminated materials and coming up with a plan to treat it during construction, whether we have to set up a waste stockpile area, stockpile the material, test it, and then decide whether to put it back into the trench or not. Depending on the type of contaminants, we may be able to put the material right back in the trench, if it's suitable for backfill, obviously. And the groundwater will be treated. Mitigation of the wetland impacts are important. And I think our plan, which I'll talk about in a minute, is try to keep the pipe close to where it is currently within that riprap causeway area. That should be the best way to go to minimize wetland problems or impacts. Wetland restoration and maintaining flow during construction. This slide is kind of a schematic showing what we're thinking of doing. Really, we believe the best option is to keep the pipe within that causeway area to minimize, to provide a work platform for the contractor to go in there and do the work until you start to remove the riprap and that. But a lot of the work can be done using this as a access. So the choices are either to keep the pipe in the same exact location or to offset it to one side to minimize the need for bypass pumping. And we anticipate we'd install cofferdams on each side adjacent to the riprap area, or at least deep sheet piling to cut off any flow. The elevation upstream in that pond is about elevation 5. Not sure whether that can be drained or not, but assuming it cannot be, it'll have 5 feet of water above the bottom of the pipe. That'll have to be cut off by sheet pile and to allow the pipe to be installed. So what we're thinking, the other option is to offset the pipe so that you can keep the existing gravity sewer operating while you put a new sewer next to it, like I show here. So this slide kind of shows the two options. This would be the case. This is the existing pipe here. This is a cross section of, well, first of all, here's the conservation area, Ash Creek to the left, and the upstream pond here. This is the existing causeway with the existing 33-inch sewer. And here's a photo of the area here. So we could either replace the pipe in the same general location, or possibly on the downstream side. It seems to be that there's more room on the downstream, or the Ash Creek side.
I think Warren's in, if you want to ask.
Okay. So just showing a schematic cross-section with new piles either driven around the existing pipe, or if we would relocate the pipe, it would just be the pile foundation would be next to it, to one side.
He has to be admitted by them into the meeting, he said.
Okay, Warren Baskey is trying to sign in.
He has to be admitted.
So if you guys could admit him to the meeting, I don't know.
I have no request for him. Nothing.
Oh, okay.
Okay.
All right, I'll
Is he using the right link?
Yeah. Yeah.
So the next slide is general description of the construction sequence, the way we anticipate it occurring. Depending on what we find with our contaminated soil investigations that Cindy will be doing, we'll install the waste stockpile area and a groundwater treatment system, install carpeted sheeting, presumably on the edges of the riprap, remove and stockpile the riprap, excavate to the bottom of the pipe. Any excavating material that needs to be segregated will be stockpiled in the waste stockpile area. It'll be tested to determine whether it can be put back into the trench. We'll install the pile vents either around the pile, existing pipe, or adjacent to it. And then once the piles are in and the pile vents are installed, that's when we would set up the bypass pumping system. We're anticipating using electric pumps with diesel backup so that there won't be any downtime due to electrical outages. Then we'll remove the pipe and put the new 36-inch in, or put it next to it while the gravity sewer is maintained. Backfilled with approved materials, dispose of any surplus material off-site at a testing or treatment facility, replace the riprap, and then restore the wetland.
Oh.
So that's pretty much how we anticipate the construction happening. The other alternatives, you could install new sewer in the pond upstream, but to us that would just be a much more of an impact on the environment, much more difficult construction, and it would also probably take much longer to construct. One thing I didn't mention is, which I think I'll mention it as we come along, it's really ways of installing the piles with the pipe in place, and I'll talk about that in a minute. But next thing I want to do is just go through our approach. This is pretty much a summary of the scope that we submitted with our proposal. And phase one is the project investigation and analysis. We'll conduct a site visit with the town, go out to the site, discuss different alternatives and what the issues are that we'll have to address during design. Then we'll collect and review all the available data that's available for the project. One of the key things is to obtain the soil boring data from the Metro Center project to determine what additional borings are needed, and also same with the environmental testing. There's a lot of information. We have some of it, but we'd probably like to sit down with the consultants that were involved in that project and get a first-hand summary of what exactly happened at the Metro Center project. We know there's a liner installed. It appears that the liner comes right up to the area where the pipe is. There are a lot of details we could work out by meeting with those consultants and or people from the town that are very familiar with the project. So we'll review all the information we have. We're familiar with the hydraulics of the system. We've reviewed the report that was written. Coordinate with the utility companies. We know there's some transmission lines running along Kennard Street that our equipment will have to pass under. We'll have to coordinate with the UI company to figure out what the restrictions will be. Initiate contact with the permitting agencies. Decide what additional field survey is needed. We already did some survey in that area. We may have to supplement it. And then during this stage, we'll also be coordinating with our subs, getting them involved in the project, both Logical, Clarence Welty, and Soil Science. So during PD, we'll be doing our supplemental survey, reviewing all the environmental data that we can get our hands on. Cindy will do some additional geoprobes, sample the soil, do groundwater sampling as well, do laboratory testing, characterize the contaminants. We will also be doing soil borings, sample the soil. Clarence will do sieve analysis and that sort of thing. If there's any rock in that area, we'll take the rock cores. Clarence will make recommendations for the construction and the pile design. And at this time, we'll be looking at different alternatives for the pile types. I believe the piles that are installed there are timber piles. They were friction piles. So I'm assuming that bedrock is fairly deep, and it may be that the piles for this project will have to be friction piles. So we'll have to look at the different options, H piles, timber piles, and micro piles is something that we've done on a lot of our bridge projects recently. And the advantage of a micro pile is it's a small drill rig. It can work, maybe it'll work right under those transmission lines, but it's you can install micro piles in the basement of a building. We think micro piles may be the way to go. Smaller drill rig, easier to get out there. Maybe to straddle the existing pipe and drill in some piles right next to it. Now we'll review different options for pipe materials. Standard RCP pipe with 8 or 10 foot lengths would mean you have pile bents every 8 or 10 feet. And we may go with a different type of material where maybe you need fewer piles, maybe up to a 20-foot span. So we'll have to look at those options together and see what's the most cost-effective way to go. At that point, we'll look at different, this is assuming, we'll also at this time be looking at the different alignments, same location, offset, or in the pond. Prepare the conceptual plans and cost estimates. Then at that time, we'll be meeting with the town, going over these options, the costs, the schedule, the time considerations, and with the town, pick an alternative that is the best option for the project.
I'm going to try to dial into Warren, or you get him on audio, or you're all set?
You're all set. Okay. As far as the preliminary design, once the conceptual plan is done and we chose an alternative that we're going to go forward with, the preliminary design is fairly straightforward. Plan profile sheets, pile design and pile details, cofferdam layout, the watering basins, bypass pumping plan. Cindy will put together a plan for handling, a spec for handling the regulated materials, plan for the wastewater stockpile area and the groundwater treatment. Soil Science will have a wetland protection plan and also a wetland restoration plan. We'll determine if there's any additional easements required. most likely at least a temporary work access easement will be needed. We'll continue coordinating with the utilities. We don't expect any underground conflicts, especially if we keep the pipe in the same general location as the existing, but we'll have to coordinate with UI for work under the wires. We think that the pile equipment won't need to operate under the transmission wires, and especially if we use micropiles. So we don't anticipate that being an area a concern. However, general excavation with the backhoe is something that the contractor will have to comply with whatever restrictions UI places on their operations. Then we'll submit the PD plan, meet with the town, go over the plans, incorporate your comments, and then go to final design. Now, permitting, we believe, is very similar to the permitting that we had to go through the same process, the same types of permits that were required on our previous project here in Fairfield. Coastal site plan, the Fairfield WPCA permit, local wetlands. We'll be doing a NDDB review with BEAT to see if there are any changes to what they told us a couple of years ago. It's something we'll have to check with them to see if there's any endangered species. OLIST, Coastal Consistency Review, Army Corps of Engineers, Coastal Permit, and the ELUR Disturbance Authorization, and Cindy will help us with that. And if Cindy's on the line, she was going to talk a little bit about some of the environmental considerations. Cindy,
Sure.
Are you there?
Yes.
Okay. So you could, I think, talk about the subsurface exploration plan and also maybe follow up on the ELUR issues.
Sure.
Hey guys, let me, Cindy, I'm sorry to interrupt, but we're just about out of time, and there's probably some Q&A. So maybe you could cover that quickly and open it up for a few questions.
Sure. I'll be brief, and I apologize. I think my laptop went to sleep, so I lost the video feed. But we had put in a provisions just initially to go out and do, like Joe said, the environmental testing to get an idea of what we were looking at for soil and groundwater conditions in the areas that weren't previously tested. And we also confirmed with the DEEP regarding what's involved for getting the temporary release of the ELUR, which it's a fairly straightforward process where you just need to submit plans of the proposed construction, the restoration plans that would be involved, and just the schedule of the proposed work.
Okay. Then we'll go to final design, which is fairly routine. Put together bid documents, and we could provide these services, typical services for bidding an award. Put together the bid documents, attend the pre-bid meeting, respond to any RFIs, issue the addenda, and review the bids, check contractor qualifications, and prepare a letter recommending award. This is the schedule that we included with our submission. It appears that within 3 or 4 months the design could be completed, assuming that and I'm assuming 2 months for permits, meaning that you could bid the job in May or June and hopefully complete the project by the end of the year. So with that, I'll turn it over to you guys for any questions that you might have.
Yeah.
Laura, I don't know if you can hear me. I don't.
Yeah, now I'm unmuted. Okay, I was directing my question to Cindy.
Sure.
I don't know. There you are. So you've done work in the town, and you're aware of how closely the Connecticut Deep is looking at any project that we're doing and conducting in town. So the environmental testing that needs to be done at this site, knowing that this was a highly contaminated site and it was remediated, but we still have the environmental cap in place. And you did say that it's a pretty quick process to get the environmental land use. You're going to be disturbing the cap and to get that form approved. I mean, and it seemed like the length of time that you had for permitting, Joe, was not very long, like just a couple of months. I don't know, dealing with the EPA and the Connecticut DEP this past couple of years, they just seem like they're taking much longer and they're looking at things much closer. And Cindy, I don't know if you could answer how long will it take to get that disturbance authorization letter? And my other question is, does Lorero, because they were the LEPs at the time, do they have to get involved with this as well and approve what you propose to do to restore that environmental cap once we're done?
Yes, I believe I said I did talk with the DEP about this just in a vague type conversation, not specifically for this, but yeah, I mean, it would be a good idea, and this was something that we were going to start right from the get-go, not wait until like the design phase was done, but just get the conversation started and keep Lorero in the loop, because I do believe the state would turn to them and have them review what we were proposing for the, especially for the restoration of the cap. So that's something that we would involve very early on in the design phase and get the conversation started, just so it didn't cause any delays once the final, the design was completed and it was going out to bid. Would have a plan in place ahead of time. Just stress the fact, and the state. This isn't a real complicated thing where it's going to be for redevelopment. The state turns around, especially municipal type projects like this that involve utilities fairly quickly, because it's basically get in there, put the pipe in, and restore it and get out. So it's not like there's going to be issues down the road for exposure, for redevelopment and whatnot.
But I just want to understand how it works. So then Lorero will continue to be the LEP that, you don't take over on that area there, do you, once you've disturbed that section and now that you're restoring it? Do they have to come out and inspect it and, give their blessing on that, and then do they take ownership of it afterwards again, like they do now over the whole site?
What happens is that the state will grant, we're going to submit plans that, the state will review, but I believe because Lorero is the one who filed the ELUR, they will have them review them as well and provide comment. And then, I don't think it's not like they're going to be out inspecting what we do, but, they're going to be reviewing everything that we submit, and it's going to be a very interactive process with both the state and Lorero to get approval for this. And like I said, it's not something that we're proposing to redevelop and build on. It's a out situation. So
right, it's a disturbance.
Yep.
So there's going to be a fee paid to them to do this work?
No, I'm not. No, it shouldn't be fee paid, because I believe the state would just kind of. The state is the one who holds the ELUR, not Lorero.
Right.
So
right. But okay.
Again, I'm not sure if they will involve Lorero, but again, our proposal to them is going to include everything that's needed, and
yeah, you have to put that cap back. So
Yes,
and
exactly.
it will be disturbed. Yeah. Okay, and the permitting, I just think is going to take a little bit longer. I think you only had a couple of months in there. By the time they advertise, and by the time I just don't know how realistic that is, and if it's realistic to get this thing constructed this year or in 2021, based on the short time frame that you have for those environmental permits that we need to obtain.
That's just an estimate. You know, we're aware many months we've done a lot of these projects, and you never know how long it takes. We've done some permits that are handled in 2 or 3 months, and some that took 12 months. So the schedule's probably a little optimistic. I don't know if the town has a definite time frame in mind, but we'll start the process as soon as we can. We don't have to wait till final design to submit the permits. We should submit them early on in the PD. If time is of the essence, if it's not, it could be that you wait.
Well, I think it is of the essence. I know that there's a contractor ready to build on that site there, so they need the capacity, I guess, in that pipe now. Right, thank you.
We'll do whatever we can to expedite the process and work with Laredo as much as needed to move the job along.
Okay. And Chris, Chris Rogers, did you have an estimate when you wanted it done, or when it's budgeted for? Or?
It hasn't been budgeted yet, so once the RFPs are approved, we'll submit and then we'll go for funding. So. But yeah, the time is of the essence. Naturally, we want to get this project moved forward as quick as possible.
Hi, Joe and Cindy. It's Bill Hurley from Fairfield Engineering Department. Is there any, we don't have much time, but is there something in your presentation or some idea or concept that you have that maybe there could be some cost savings involved, either for design or for construction?
Yeah, we'll look at that during preliminary design, but that'll go into the options. Minimizing the number of piles that you need is one thing. We'll have to be looking at using a different pipe material, concrete cylinder pipe. Maybe you can do a 20-foot span instead of a 10-foot span, so that would minimize the number of piles. Bypass pumping is a big issue. It could cost, $20,000 to set up the bypass system, $20,000 a month to rent the pumps. So we could save some time or cost with the bypass pumping if we're able to do a lot of the work before, while the flow is maintained through the existing gravity line. So that's something we're going to be looking closely at. The buffer dam, if the pond can be, which I don't think it's possible, but if you could draw the pond down, you might be able to eliminate some of the sheeting that's needed. We were thinking the sheeting adjacent to the riprap would be a good thing anyway, just to keep construction contained, and not disturb the pond. But if the upstream pond can be dewatered for some reason, that would help with the dewatering. Cindy has thoughts on the treatment of the material that we remove. It may be possible to test the material so that we know right away whether or not it has to be stockpiled or whether it can be shipped off to the treatment facility right away. So that cost maybe could be minimized. but between the piles and the pipe material and the bypass pumping, I think those are the big issues. Also using temporary sheeting in the deep cuts to minimize the extent that we disturb the wetlands is probably another thing that in the end will be a significant cost savings possibly.
Yeah, I like the bypass slide that you presented. That was really informative. And then any idea maybe on saving for dewatering costs?
Well, I think, if you can drive the sheet pile deep enough to cut off any flow from underneath, I think it should be minimal because you're only talking 5 feet of head above the pipe. And the pipe is sitting on piles, so you couldn't, the existing pipe's on piles, the new pipe will be on piles, so dewatering is really not that big an issue here. You could almost put the pipe in the wet and backfill with full fill or something. But I don't think it'll be a problem. It's not a lot of head that we're trying to cut off here. It's only 5 feet at the most. So with the sheeting and a small pump, they should be able to handle it, I would think.
I have a question for Cindy real quick. The kind of material, I know it's casting sands there, if we remove the sheeting used for the cofferdam, is that going to have to be decontaminated? Because that's going to add an expense, and I'm just wondering if that would be the case here.
Yeah, it's going to depend on, exactly where it is and what's in the soil at that particular point. If it's nasty material that's oily and potentially has hazardous contaminants in it, then sure, it's going to have to be decontaminated. But it's hard to say right now without knowing exactly what we're talking about in terms of where we're have.
All right. Thanks.
But real quick,
well, we know they removed the material down to elevation 0, and I'm assuming that was because for all that they found there's no contaminants. If that's the case, then hopefully we don't run into too much of that material, in the area where the pipe is.
Yeah, but there's the cap upstream over those casting sands, and you don't know what's below that.
Okay.
And that's what worries me a little bit.
Well, if we could, it's possible that they can do this work without deep sheeting, and they might be able to even use, for bridge jobs, they use very big sandbags that are placed on the surface. And it's possible that they'll be able to cut off the flow underneath and not even need sheeting. So that's another option. With these big giant sandbags, you might have seen them, about 5 foot by 6 foot. You place them along the toe of each side of the causeway. That may be enough to cut it off.
Maybe. Okay.
Handle whatever flow comes underneath with pumping. So that could be a cheaper option.
Yeah.
Guys, in fairness to the other groups, we're approaching 50 minutes, and we limited the other groups to 40 minutes at max. Okay. So I'm gonna call to the discussion, and thank you for your presentation and for your time. And we will reconvene at 3 or 3:30. 3:30.
Mm-hmm.
Okay.
Okay. Thank you.
Pending no snow.
Yeah. Okay. Thank you.
Thank you.
Thank you.
Okay. Bye-bye.
Right on time. Okay, Team Wright Pierce, welcome. Let's see, we have Laura,
Yep. Hi.
We have Laura. We have Bill Hurley.
He should be signing on momentarily.
Okay. Chris and Dennis and Tom. What I think we've found helpful is maybe a 15-20 minute overview of the presentation and then opening it up for Q&A.
Yeah, we tried to time our slides to be about 15 minutes, just sort of going over our little. I'm not sure I can see everybody that's on. Dennis, are the H&A folks on?
Rich, are you on? Is that Tim? Rich or Tim, are you on?
Yep, Tim. I'm sorry, I was muted. Tim Kroll is here.
Okay. Great, thank you. Oh, and there's Rich. Okay, everybody's here from our end.
Okay, just give us 1 minute.
Sure.
Okay.
I'm here, Chris, if you're waiting for me. I don't know who else.
No, we got you.
And Dennis, hopefully we'll see you again next month. We missed you at our monthly meeting. Wasn't the same without you.
Oh, geez, I know. You threw me a curveball by moving it up so early.
We did. I know we did. Yeah.
Yeah. No, I apologize for that, but Chris covered for me. From what I understand, Chris and Bill covered for me.
They did.
Great. All right. Let us know when you're ready.
Yeah. Why don't we? Given that snow's on its way, let's get going.
Okay. Great.
So we're all set?
We're all set.
Yep.
All right. Well, great. Well, thank you, everybody, for inviting us here today. Again, like we said, we just wanted to give a brief overview of our previous submittal. I think you know who Wright Pierce is, so we won't focus too much on that. And some of the types of work we do, and mainly focus on our approach to this project. So just a little about who the folks are online here with us today. My name is Chris Pierce. I am the head of our Connecticut Wastewater Group. I would act as principal in charge for this project. We've also got Dennis Stivert, who you know. Dennis would be our project manager. And then Tom Simbro would be a technical advisor for us. Tom has been with us for a number of years, and prior to working with Wright Pierce, worked for a utility contractor, actually installing these types of pipeline projects. And then we've also got a couple folks from Haley and Aldrich on the line, Rich Genovese and Tim Kroll. Hopefully I pronounced the names correctly. And then just, some of the other folks we could have on our team here that was also listed in our submittal. Most of these folks are in-house. We've got Haley and Aldrich would be doing the geotechnical and environmental site assessment type work. We'd be working with JKB Consulting, Julie Bjorkman on permitting, and using Jason Edwards for the survey and wetlands delineation. With that, I'm going to turn it over to Dennis to start going through some of the key issues that we see on the
Thanks, Chris. All right, so just, some of the key issues identified in the RFP, and then also just from internal and external discussions here on this project. Obviously, the survey is critical and the wetlands delineation. We see from the information provided, there's been quite a few number of surveys done in that area, it appears. The big question is, can we reuse those surveys, or do we need to do a new survey? So that would be one of the first things that we would want to figure out based on discussions with the permitting folks. The need for a new, fresh survey may be a requirement of some of the permitting. So with respect to permitting, there was a number of permits that have been identified as potentially required here. You have the State of Connecticut Flood Management Certification, obviously the NDDB, which is the National Diversity Database for Endangered Species, OLIS, which is Long Island Sound, Coastal Consistency Review, Army Corps of Engineers, and of course, any local Fairfield inland wetlands reviews, as well as Fairfield street opening permit, depending on the limits of the project. Go ahead, Chris. Again, additional key issues. Obviously, this is a wetlands conservation area. Back when the Metro Center, when they increased the pipe size of the Metro Center to 36-inch, there was some significant remediation of casting sands on the property. As a result of that, a 40 mil poly or HDPE liner was placed down. It's hard to see, but up in this upper enlargement A plan, over to the right-hand side, on the right side of the concrete weir wall is the poly. Before we could do any work, not even construction, but investigative work in this area, specifically related to the geotechnical and the soil borings, we would need to obtain permission from the DEEP to lift the ELUR, which is the Environmental Land Use Restriction. And Haley and Aldrich will speak a bit to that on the next slide. They have a lot of experience dealing with these types of sites and what needs to be done to obtain permission to get in there and actually start drilling. Also, with respect to Haley and Aldrich, some other items that they will discuss would be the soils in general. What's under the ground? What are the subsurface conditions? The best method of excavation support. The soils themselves, as they do the borings, they will sample them. On this particular project, there is known or suspect soil, so we will conduct soil sampling ahead of time and not during construction. It'll all be done. The soils management plan will be generated, and it'll be the responsibility of the contractor to conduct that remediation. With respect to getting into some of the preliminary work, before I turn it over to Haley and Aldrich to discuss their approach to the geotechnical evaluation, I will just say that having Julie Bjorkman on our team from JKB Consulting we've used her in the past on many of our large permitting efforts. She really does a great job leading the charge. She'll set up a pre-permitting meeting with all the folks at DEEP. Typically, we go up to their office and have it, but with COVID, that may be via Zoom or WebEx or some technology like that. So Julie's been very helpful to us in really fine-tuning the permitting requirements on a lot of our projects. So with that, I'd like to turn it over to Haley and Aldrich to speak a bit about how they envision the geotechnical and environmental evaluation going on this site. So thank you.
Okay, thanks. So this is a pretty complicated little site. There's a lot going on over a pretty short distance. So we've got, right now we're planning 4 test borings, which, on a normal job, you wouldn't have borings spaced quite as tightly as we do here, but we expect that there's a lot of potential for variable subsurface conditions along the alignment. There's a couple older borings out there that show on the west end, the old borings refused at about 9 feet or so on either rock or cobbles or boulders and some kind of rock fill. It's a little uncertain at this point in time. And then on the far eastern end, the borings went down to 20 feet and still hadn't hit any kind of rock. So we expect there could be a lot of variability. So we wanted a tighter pattern of borings to help us really better define what the subsurface conditions are and allow our design to reflect that. So in addition to just changes in depth to rock or potential rock fill, we've also got the situations of just existing fill thickness, the presence of organics. How thick or deep are they? What are their limits in plan view? So that's the reason for wanting to have a tighter boring pattern. These borings are going to be about 40 feet deep. We've got an allowance to core a little bit of rock if we find some shallower rock. And that's primarily just to prove out that we're either on rock or find down if it's some kind of rock fill. And we'd want to try to understand that pretty well also. So we would use the information from the borings to help us identify what the right foundation solution is, but also just to help design excavation support and groundwater cutoff, which are going to be equally important for this project. We plan on accessing the site through a gate at Kenwood. and we would be using ATV-mounted drilling equipment. We recognize the sensitivities of working in this sort of an environmental area and a wetland area. So we have included allowances for sediment and erosion controls, matting, reseeding, things of that nature, to just be responsive and respectful of the site conditions. So the easternmost of the 4 borings is going to be located within the limits of the ELUR. So before we could do any work there, we'd need to submit an application to DEEP for their review and approval. Basically what it is we kind of have a template. We've done this any number of times before. And what we would do is kind of just describe the program. What are we doing? How are we going to do it? When? How are we going to repair the liner when we cut through it? How are we going to manage cuttings that are generated as part of the drilling program, which will also include a soil management plan just for the exploration program in that area. In our experience, this process with DEEP takes about 2 or 3 weeks to go through. So, it's pretty typical. I think, it's something that's routinely done on their end as well. So I don't think we're asking for anything that's going to be exceptionally difficult from their perspective. In addition to working with DEEP to drill in this area, we also recognize that there are going to be needs of the local Wetlands Commission. Again, we understand what it's like to work in these kinds of sensitive areas. We do it all the time, and we know that there are people who are always watching what's going on there. And again, we're prepared to accommodate whatever measures a local Wetlands Commission may require for us to be able to protect that area while we do our work. So not only are our explorations planned for geotechnical design, but they're also integrated with our environmental soil management program. In addition to having geotechnical engineers on staff, we also have a number of licensed environmental professionals. So this is, again, something that we do pretty routinely. Our program includes 3 soil samples, which we would distribute through the fill and organics, most likely, and those would be submitted to a state-certified laboratory, and we'd run the Massachusetts landfill package on those. And that's basically a suite of analyses that help us, that we can use to compare to Connecticut requirements, and so we can understand if we can reuse the materials on site that might be generated during construction, and if so, what would the restrictions be for reuse? Or, for materials that ultimately need to go off-site, what type of receiving facility would they need to go to? And that will help the team come up with an idea of what the estimated cost for that soil management is up front, so that you're not getting surprises during construction. It can all be established so that the contractors have that information for the bid. We also plan to take 1 groundwater sample. If existing well MW8 is accessible, we'll use that. Otherwise, we'll install a well as part of our exploration program. And we would also submit that to a lab to support, and for chemical analysis, to help us support any kind of dewatering discharge permits that are required, and to understand whether construction dewatering discharge would either need to be through a sanitary sewer line, or if we could put it into a stormwater system. So that would be the benefit of the groundwater sampling. I know I rushed through it a little bit, but trying to keep things moving. So certainly happy to answer questions if they come up later on.
Great. Thank you. Thanks, Tim. All right. And again, I'll breeze through this slide, but once Haley and Aldrich completes their investigatory work, we will continue to work with them throughout the final design, developing the soil remediation, the soil and or groundwater remediation plans, the actual design of the new piles, the design of the location of the sewer, whether it be in the same trench or not. I'll turn it over to Tom on the next slide. He'll talk a bit about some of the alternatives and the construction sequencing ideas that we have. And then again, come up with a cost estimate and assist the town through bidding. At this time, the RFP goes through bidding. So. I do have one example. Recently in Guilford, Connecticut, we installed some new water mains to serve areas of town that were on wells. As part of that project, there were 2 tidal stream crossings and a bridge crossing, and we implemented helical piles to support that piping across the through the tidal stream crossings. Great. Okay, thanks. I'm going to turn it over to Tom to talk a bit about some of the alternatives and sequencing.
Yeah. Hello, everybody. Can you hear me okay?
Mm-hmm.
Great. So I've been doing pipeline design work for about 33 years, and it's kind of my specialty. Prior to coming to Wright Pierce, like Chris had said, I worked for a general contractor, a utility contractor, that specialized in really difficult conditions type of pipelines, sewer, water, and gas. And really the bread and butter of the company was big pipeline jobs that required bypass, dewatering, pier construction, bridge crossings, marine. And so coming to Wright Pierce, I'm really taking on a specialty role working with everybody to go over constructability analysis and cost estimating. So Chris and Dennis showed me this particular project and showed me the existing design, and it reminded me of a particular project that when I was with a general contractor that we had constructed. This was a pipeline. It was a replacement of 700 feet of 20-inch force main for in Providence for the Narragansett Bay Commission. And the two photos you see, the one on the left and then the one on the bottom right, it was a marine crossing. It was a pond crossing. There was an existing force main that was there that was going to be abandoned in place. But we had room to move over and build a new one. But one of the things, this was at a dam, just upstream of a dam, this reservoir. So the soils were unbelievably soft from sediment deposits. So the way we designed this and built it was actually similar to what the existing one is with timber, only we used helical piles with structural pile caps and a beam across to support the pipeline. So what you can see inside the cofferdam, this is how the job started. Over in the cofferdam, you can see we drove two helical piles, one on each side of the pipeline. We used a template to do that, and we would drive the helical pile until it started to auger in and get a bearing load capacity. Then we would assemble that, pre-assemble that beam and pile cap supports there. Those pile caps were all designed and fabricated. We worked with CCI over in Putnam, Connecticut. But it's a very similar design. And in looking at your particular situation, I could see that this could be a potential solution. And we'd have to work with our geotech on this, obviously. But, one of the things about the similarities is that, it was a very ease of construction, small equipment being used, low clearance. When we did this job, we were highly sensitive there was high voltage lines above us that we had to cross. Yeah, you can see it right there, which looks, similar to what you have. So if you're going with like a traditional pile, the pile could be 20 feet tall, plus you'd need to boom it up. So you get pretty close to these high tension lines, where with the helical piles, they only come in short 5-foot sections. So you really are in a small machine and you're only about 5 feet off the ground, 6 feet with the torque head. So it was really, the crews it was really cost effective way to support it. The contractor Helical Drilling out of Boston was, cost effective. All that fabricated steel from CCI was very reasonable. The only thing that cost a fortune was the barges and the divers. But other than that, we don't have that problem on this one. So anyways, we've used that helical piles. We could go with the traditional. We've also done a job where we went through some wetlands, a marshy tidal area where we used geopiers, which is basically 4-foot diameter. You drive 4-foot diameter, you auger out material refill it with processed gravel, and you ram it, compact it, and you do that ahead of the job. And then when you come back, your pipeline job, you follow the same line. And when you're excavating, you're hitting nothing but bearing capacity soil. So there's a couple of little tricks that I've seen done. And once we get the geotech information, I think we'll be able to come up with, a constructible, cost-effective solution. So.
Great. Thanks, Tom. One last thing was, Chris, I'm sorry that we didn't talk about bypass pumping, but I think if we went with whether it's if it's in the same trench in the same location, we'd have to bypass pump around. So that would be part of the permitting effort. And again, if we were to go with an alternate route, we may be able to potentially leave the existing line in service while we construct the new one and then swap over to the new line without the need for any bypassing. So, all right, go ahead, Chris. Thank you.
Dennis, just a summary from our submittal. We put in a project schedule showing the initial couple of months for the site investigations. As Tim mentioned, it could be a 2 or 3 week process with DEP getting any permits for the ELUR. You never know with DEP, so that could impact that. But depending on the DEP schedule, this is kind of what we'd anticipated for doing the investigations and the design work through most of next year and being ready for construction the following year. And with that, we'll wrap things up. Want to present our team to you. We've got folks with a lot of experience. Like Tom mentioned, he's been doing this 33 years. The folks at Haley and Aldrich have been doing this for years. Dennis and I have been working on wastewater projects together for the last 19 years here at Wright Pierce. We'd be managing this out of our local Middletown office. Tom comes to us from Providence. Between all of us and the other folks on our team, we've got decades of experience doing this type of work, and we've got some folks that can put together some innovative design ideas. So with that, we'll wrap up our presentation and turn it over to any questions you have.
I had some questions. I'm the one going first, I think. I think for Tom, you had mentioned only taking 4 soil borings in that area. Is that correct?
That was Tim from Haley and Aldrich.
Yeah.
So
our program includes 4. That's correct. 4 test borings.
All right. What about
75?
Okay. So what about testing for contaminated soils and the constituents that could be found in the soil? Do you think 4 is enough? Would more be needed?
Yeah, I think that we would definitely look at the variability in the conditions that we find when we are doing the borings, and if we found that there was something that was more variable than that, we could always think about adding some test borings to the program. But I think in our experience, it's a pretty tight pattern over 300 feet. You've got your boring space, give or take 50 to 75 feet apart. So I think that's a pretty good sampling. I think that the frequency of samples per volume of material that would be excavated would certainly be, fall within the typical range that a receiving facility would be looking for.
Okay. And you touched on dewatering. I know the problems that we foresee is the bypass pumping, so that if that could be minimized, that would be excellent. The contaminants that could be found, we know that this was a Bullard's. It was a factory that the site was highly contaminated, and it does have that ELUR on it, and that cap is very close by, which means that there's material potentially underneath the pipe that could have contamination in it. And the DEP is just really watching over the town of Fairfield with issues that have arisen in the past. So they're really looking at every time we put the shovel in the ground. We're actually using helical drilling on a project for in the treatment plant. I'm sure, Dennis, you know about it, but it's about 60-70% complete now. So they're doing a nice job. They came down from Boston, and they're the subcontractor for our contractor.
Yeah.
But so the bypass pumping is critical. We had problems there when they bypassed to put another sewer line in for the Metro Center upgrade. And if that could be minimized, just offsetting, that was good. And the permitting and the length of time it may take to get permits is another concern. But putting the pipe in is easy. I think it's just getting past all these other obstacles.
Yeah. Yeah, and with respect to the permitting, we don't know what types of restrictions they're going to place on the times of the year that we could actually do the work. So, it may be limited to dry summer months or even in the winter time when it's frozen. We wouldn't really know that.
Right. And it's all in a conservation easement, all this work too, so. There's inland wetlands to deal with, the Conservation Commission to deal with, plus all the other agencies.
Yeah, one idea that I had for the bypassing, if we couldn't relocate the pipe, we could potentially hang the bypass piping off of that walkway. And also one other thing we've done in the past is, they'll let you, if you get it approved, you could just have the pipe could just lay across the marshy area.
Yeah.
And it just goes up and down with the tide. We've done that before as well. So.
Right. Right. It's the backup or the keeping up with the high flows, because this line takes in a lot of water from. There's a lot of inflow, as you know.
Oh yeah.
Dennis, right. It varies quite a bit, and for a bypass pump or pumps to keep up it's difficult, and you don't know that there's a problem until it starts coming out of the ground or a manhole way upstream.
Right.
So they have to be sized. That's a concern that I have with a long lasting bypass that's put in place.
That's one of the other things Tom brings to the table. He's been the contractor that's had to make sure those systems get installed and function properly.
Right.
Yeah, we did a lot of work with Godwin in Connecticut with bypass, 20 million gallons a day plus.
Okay.
Setting up multiple, units, sound attenuated. I don't think sound attenuation would be as critical over here, but making sure that you're prepared for wet weather or any kind of storm event. That if it's typically 3 MGD, but it can, like in Newport, we did a job in Newport that was average day was 3 to 4 MGD, but wet weather in Newport went to 20 MGD. Yeah. So it was that much of a drastic change. So
I think here it goes to 11, doesn't it? Something like that.
Yeah, about 11. Yep.
So it's drastic.
Yeah.
Yeah. No, that's real flow.
Yeah. All right. Thank you.
Sure. Any other questions?
Yeah, sure. This is Bill Hurley from engineering. Hello, everyone. Just wanted to go over, we're going to have to decide which consulting firm. They're all good. What do you think would separate yourselves from the others? And do you have any cost-saving concepts so far, knowing a little bit about the project?
Chris, I'll let you take that one.
Okay. Yeah, I guess, what we think we've tried to do here is we've, tried to put together a good team with a lot of experience in all the different types of areas that we think, we're going to hit here. We've got our very experienced geotech team. They also have their licensed environmental professionals on staff to take a look at the potential soil conditions, contamination, things like that. And then we've got, Tom coming in from a constructability point of view on, really understanding how these things go in the ground and how much some of this stuff costs depending on the different approaches it takes. We think that really puts a very experienced, strong team together for the town. As far as cost savings ideas, the one thing we've been taking a look at, again, we need the field investigations to determine, but, if you can get a parallel pipe in here, then you could at least minimize, if not eliminate, the bypass pumping and only need to bypass, when you're making final connections. I think that could be a way to save some costs. But again, as we get into a little more detail, just some more of the field investigations, we'll be going over all the different alternatives, how to get this in most cost effectively and address all those other concerns. Looks like everybody's on mute now. I don't know if anybody is asking another question.
And the dewatering issues, you had mentioned that you're going to test to see how that would be treated if we could discharge it to the surface waters or into the sanitary sewer, right? Depending on the amount, what the test results show. I mean, I think you touched base on that as well, right?
Yeah, that's the purpose of sampling from one of the wells on site, right? Is to understand the groundwater quality and any implications that has for discharge of dewatering effluent from an environmental standpoint.
All right. I like the use of the helical piles because you're right, it's less costly, it's less intrusive with the big crane. You can go in with the smaller piece of equipment to install them. And this photo that you have showing what you did in Providence, I think you said, is that Providence?
Yeah.
Yeah.
Yes. Yeah.
Yeah. That looks good.
Yeah. That job came out very well. The other thing too is when you drive a typical pile, it's vibrated down. With the helical, there's really no vibration.
No vibrations. Yeah.
You're not worried about. But the problem with the helical is we looked at it for some other locations where it doesn't work. Like if ledge is close to the surface, because you can't bite into anything, So but there's other ways to handle that too. So, but I do like the helical, and when I saw the overhead lines too, this crossing is. It really is a nice alternative to do it that way. So,
and there is another variation on that too, which is called drive catch piles, which is also something that uses low overhead type equipment, and it's simply installed with a rotary action as opposed to any kind of driving. So there'd be a few options like that we could take a look at.
Okay. Okay.
Any other questions?
No other questions for me.
Great. All right. Nice work, guys. Well done.
All right. Thank you. Thank you. Good luck with the storm, everyone.
Yeah, good luck.
Yeah.
It's getting dark out.
Get home safe.
All right. Take care. Thank you.
Bye.
Thanks.
Thank you all.